This is a brief introduction to some of the principles of user interface design. So, user experience or UX is important in all design, but it's particularly associated with interaction design because of the dialogue between the user and the system. Um, in graphic design, a lot of times what we're creating are single graphics that are meant to capture attention and then communicate a message. When we're designing screens, we are often designing a whole system of interactions between, software and the user, or to help the user accomplish a task. And the method that that dialogue takes place through is the interface, and that is what UI is, or user interface design. There's a lot of semantics that surround this, and there's constantly an argument or a renegotiation between practitioners and um, job titles or job requirements between what is UX and what is UI, and who is expected to do what, and how much should you know within the discipline. But the point is the same, and we're not really concerned with the difference too much here in this course. The point is to do good human centered design. So, over here on the right, you can see some of the overlaps between different disciplines of design. And the truth is, you will probably transition between many of them as you're working. But a lot of it is user experience design, or has to do with how the user is kind of encountering their problem, discovering your product and using it, all the way through to either getting rid of the product or extending that experience beyond the initial interaction. A lot of the important ideas in UX can be found in Don Norman's Design of Everyday Things. This is a book that should really be on all designers' bookshelves, and I highly recommend you read it. But some of the key points here are coming from this text. And a lot of what it boils down to is that good usability is invisible. We really don't think about the design of a lot of interactions unless it's going poorly. And in that case, it becomes incredibly frustrating. The classic example of this is the Norman door, which comes from that example in that book. So I want you to think about how you would fix this, or maybe, what is even the problem of this? Well, we have a couple of signals going on here in the visual. So the plate says push, it's a push plate. However, we have a handle on the door that allows us to pull on it. And this is a conflict in signaling. So is it a push door or is it a pull door? If it's a push door, we could get rid of the handle entirely so that we could only push the door. If it's a pull door, then it shouldn't say push. So the world and the way we interact with objects has natural constraints and affordances that we can discover. In digital interfaces, these things don't exist because they're not physical objects other than the phone or computer that we're interacting with. So we as designers have to consciously add those affordances and constraints in. Oftentimes, when a digital product is frustrating, it's because those things aren't there in an appropriate way, and it results in poor usability. An affordance, to put a definition on this, is a relationship that can exist between two objects. In our case, this is often the relationship between us as the user and the digital screen. So some examples here would be a doorknob affords turning by a hand. It has that property. A chair affords sitting by a person, but it also affords sliding, lifting, or toppling. These are all things we can do with a chair if we wanted to. Glass affords light to pass through. It does not afford air to pass through it. Really good exercise to think through what is an affordance and what are constraints are to take a look at some of these objects designed by architect Caterina Camprani. So these are funny, but they're also very helpful to think about. So if we think about what makes a fork work, it affords us to push the tongs through the food so we can stab it. The rigidity of the handle of the fork is what affords that. If the middle of the fork is created with a chain, that affordance is lost, so the fork doesn't work. Here you can think about a big pot of soup or boiling water. Having the handles on opposite ends of the pot affords us to hold it level. If those handles are too close together or on the same side of the pot, that becomes much more difficult, or we lose that affordance. A key affords turning through leverage. It also affords us to pull it back out of the lock with the head on the end of it. This is a good example of a constraint. A mug with a vertical handle constrains us to holding the vessel upright. If this handle were horizontal, it would be much easier to spill the drink. A more practical example of this is the difference between USB-A and USB-C. So a USB-A plug has a constraint that only allows us to plug it in the correct way. Oftentimes you're flipping it around trying to make sure that it's going into the plug in the right side up. However, there are no signals on a USB-A to signal which is the right side very often. Sometimes the little icon is on the top side, sometimes it's not. USB-C is much friendlier to use because it's afforded the ability to plug in either direction, and it works in either direction, so it's much friendlier. This gets at kind of the way that we actually move through the world. So we've talked about how people actually look at websites kind of like they look at billboards, where they absorb about 10% of the information on the page. And that's because we use a lot of mental shortcuts to move through the world. Our brains work in a way where we operate and know only what is good enough to accomplish the task, and we don't expend the extra energy to know everything. This is because this reduces cognitive load, or the mental effort that we're putting into a task. So to highlight this, take a look at this grid of pennies and take a guess at which one is the actual design of the face of a penny. So we've all seen pennies for at least several decades now, depending on how old you are. But you probably don't have a great idea which one of these is correct. The correct answer is A. And the reason that you probably didn't know that is because you only remember enough about a penny to be able to differentiate it from the other coins in your pocket. So this course can't go super deep into UX theory, but when we're applying it to user interface design, Jakob Nielsen's 10 usability heuristics are a good rule of thumb to follow. And my hope is after this lecture, you have a better understanding of the conventions of why digital interfaces look the way they do and how it helps users operate in a less frustrating way. So the first rule is visibility of system status or feedback. So if we look at something like the menu of a website, the highlighted tab tells me where I am in the site. A load bar also makes the system status visible. So if a page was loading but you had a blank screen for 5 seconds versus if you had a progress bar loading over the course of 5 seconds, the screen with the progress bar is much less frustrating because you can tell what's going on. The second is to make sure that you are creating a match between the system and the real world through natural mappings. So an example here, you can see how awkward it is if the vertical slider is arranging left and right options, or when our arrow keys are positioned to point the opposite direction. Obviously, you can think of some ways that this could be fixed. Some real-world examples of this are if you think about a stovetop, which is arranged in a grid of 2 by 2. If your dials for the stovetop are in a straight line, it's more difficult to tell which one is which burner than if our dials were also arranged in a 2 by 2 grid. 3 is to provide user control and freedom. So you can see in this example of the composition page of a tweet, the screen provides the user the option to cancel or leave that action. You can imagine how frustrating it might be if the system forced the user to post the tweet once they started composing it with no option to back out. 4 is to have consistency and standards. This is why a lot of digital interactions follow the same patterns, because users get used to something, and so it's helpful for us to follow those patterns that the user expects. So in this example, we expect a checkout on a website for our shopping cart to look like something on the left, or maybe a bag icon. We could probably figure out that we could get to the checkout by clicking on a cash register icon, but we don't see it very often, so this would be a less correct way to design our interface. 5 is error prevention. So you can see on this screen before the user exits out of the page, if it's not saved, the system says, hey, you want to save your changes before leaving this page because you've done a lot of work and that work is not going to be saved if you exit right now. Here's another example. This is a screenshot from Google Slides. You can see when the image is selected, all of the format options that don't apply to images are grayed out. So for example, I couldn't create bullet points within the image when I have the image selected. That only works for text. And so the system is preventing me by causing an error by not allowing me to select that option. 6 is to provide recognition rather than recall. So in this example, you can see that in a login screen, oftentimes we have a show password option, and this allows us to recognize what we've typed instead of forcing us to remember it. Seven is to provide flexibility and efficiency of use. So an interface where you can drag and drop a file or browse for the file, whatever is most convenient for that user, is better interaction design than if you're forcing the user to accomplish a task in one way rather than providing options to them. 8 is to provide aesthetic and minimalist design. There is a psychological phenomena where we think that things that look better perform better, which is why visual design is important not just to how something looks, but to the experience of it and how we think it functions. So in this example, this is a screenshot from Typeform, which is a survey or form filling software. And we can compare that against Google Forms, which works perfectly well. But because Typeform is so joyous and aesthetically pleasing to use, they've been able to build an entire business model around it. 9 is to help users recognize, diagnose, and recover from errors. This goes hand in hand with error prevention. So if an error is made, your system should be able to recognize that that has happened and help explain it to the user. So here, the screenshot from Gmail says, hey, you wrote that there's a file attached here, but we don't actually see a file here. Do you want to attach the file before you send it? In 10, if all else fails, make sure that you are providing help and documentation so that users can better understand if their mental model doesn't match what the designers set the system up to be. They can understand how the system is meant to work. So I hope this helps you think about digital interfaces differently, and the next time you are interacting with software or see a screen layout, you have a better idea of why that screen is designed the way it is. And you're able to think about what are these different heuristics that the design is following to help the user have a better experience.